Once dismissed after losing the race for NASA's commercial crew contract, Sierra Space's Dreamchaser has made a remarkable return, stronger than ever. While Boeing Starliner has struggled with delay after delay, Dreamchaser quietly evolved in the background. Now, after almost a decade of hard development, one successful test flight has turned everything around. It's caught NASA's attention again, and with another flight lined up soon, Dreamchaser could not only beat Starliner but even become a serious rival to SpaceX's Dragon. How did this dramatic comeback happen, and what could it mean for the future of space travel? To understand that, we need to go back to 2011, when NASA retired its legendary Space Shuttle program. At that time, a new wave of spacecraft was being developed to fill the gap. Among them was Dreamchaser, a sleek, reusable spaceplane designed by Sierra Space. Its design was based on NASA's experimental HL-20 concept from the 1990s, which was never flown but showed great promise for safe crew transport. Dreamchaser quickly became one of the most talked about spacecraft concepts, especially because, like SpaceX's Dragon, it came in two versions, one for cargo and one for crew. While the crewed version is still in development and is expected to launch in 2026, the cargo version is almost ready for action. Known as Tenacity, this uncrewed version is built to deliver supplies to the International Space Station. Originally, Sierra Space aimed for a much earlier launch, but it's now scheduled to fly in May 2025. The project faced significant competition from SpaceX's Dragon and Boeing Starliner, and in 2014, Dreamchaser lost out on NASA's commercial crew contract. But instead of walking away, Sierra shifted its focus and adapted Dreamchaser for NASA's cargo missions instead. In 2016, that strategic pivot paid off. NASA selected Dreamchaser for its CRS-2 contract, a follow-up to its earlier commercial resupply efforts. The contract was valued at over $1 billion and gave Sierra the chance to prove Dreamchaser's worth as a reliable cargo vehicle. After years of setbacks, testing, and improvements, Dreamchaser is finally set to fly under this contract. The first of 6 scheduled flights will launch in May 2025 on the Demo 1 mission. While the original goal was to wrap up these flights by 2024, the COVID-19 pandemic and technical delays pushed things back. NASA has now extended the contract deadline to 2030, giving Sierra more breathing room. And just in time because NASA really needs it. Recently, Northrop Grumman's Cygnus cargo spacecraft ran into serious trouble. A key component, the pressurized cargo module for the NG-22 Cygnus mission, was damaged while being transported. The damage was so severe that it couldn't be repaired in time for its scheduled June launch. That's a huge setback for NASA, which now has to shuffle its schedule. The NG-23 mission has been moved up as the new priority, but it won't be ready before September. To manage the gap, NASA will rely more heavily on SpaceX. If NG-22 can't make it, the next SpaceX Dragon flight, SPX-32, will pick up the slack. Instead of carrying mostly science experiments as usual, this mission will shift toward delivering essential supplies to the ISS. But this situation highlights a major risk. NASA depends heavily on a small number of private providers. If one fails, another has to pick up the burden. That's why NASA has always tried to diversify its spacecraft options, including Dreamchaser, Starliner, Dragon, and Cygnus, to avoid putting all its eggs in one basket. This approach offers several advantages. First, it gives NASA backups in case of technical failures. Second, it helps prevent any single company from monopolizing access to space, which would not only be risky but could also lead to increased costs, fewer innovations, and scheduling bottlenecks. With multiple spacecraft in the mix, NASA fosters healthy competition and ensures resilience across its spaceflight programs. This is exactly why Dreamchaser's development has recently gained renewed momentum. It fills a critical gap, especially now that other spacecraft have hit snags, and keeps the entire system moving forward. One of the biggest milestones for Dreamchaser came on December 5 last year, when NASA and Sierra Space ran a critical joint simulation exercise. The goal was to prepare flight controllers for Tenacity's upcoming ISS mission. Jeremy Owen, head of Sierra's Flight Director Office, said the simulation was a key step toward readiness. But the testing didn't stop there. Engineers at the Neil Armstrong Test Facility in Ohio placed Dreamchaser and its cargo module, named Shooting Star, on the world's most powerful vibration table, simulating the forces the spacecraft will face during launch. Next came thermal vacuum testing, where Tenacity was subjected to temperature extremes ranging from -100 degrees Celsius to +120 degrees Celsius, mimicking the harsh conditions of space. The goal was to ensure that Dreamchaser could not only survive but operate smoothly in such environments. Engineers tested whether it could power up, regulate its internal systems, and transmit valuable scientific data while in orbit. Once that was complete, the spacecraft was transported to Kennedy Space Center in Florida, where additional tests were carried out, including acoustic checks, electromagnetic testing, and installation of heat shield tiles for atmospheric re-entry. Sierra Space also made sure that astronauts were prepared. On February 6, the company posted on X that Japanese astronaut Kimiya Yui had joined a Dreamchaser simulation the day before. The training focused on in-orbit operations, preparing Yui for his upcoming mission to the ISS. These training efforts, combined with exhaustive testing, show just how seriously Sierra Space and NASA are taking Dreamchaser's development. They're not just building a spacecraft, they're building trust, reliability, and a potential future pillar of ISS resupply missions. If Tenacity performs well on its first flight, it could shift the balance. That first test flight is now just around the corner. Planned for launch next month, it will be Dreamchaser's big moment to prove itself in space. The mission will include on-orbit demonstrations designed to show the spacecraft's full capabilities and reliability. It'll also mark Dreamchaser's first flight on ULA's new Vulcan Centaur rocket, which adds another layer of excitement and risk. If successful, Dreamchaser won't just be a backup option. It could be a top-tier competitor to SpaceX's Dragon and Boeing Starliner. For now, all eyes are on Tenacity, and the countdown has already begun. The upcoming mission will mark the first real-world test of both the SSRMS and Canadarm2 for docking with the International Space Station. This is a critical milestone for the Dreamchaser spacecraft. Teams from NASA's Kennedy Space Center in Florida, Johnson Space Center in Houston, and Dreamchaser's Mission Control located in Louisville, Colorado, will be monitoring every aspect of the flight. Sierra Space's pilots will handle the spacecraft during launch before transferring control to the company's ground team based at Kennedy. Once the mission wraps up, they'll oversee landing operations, signaling a new phase in Sierra's rapidly advancing space ambitions. If this mission succeeds, it's going to send a loud and clear message to Boeing. The message is simple: keep innovating or fall behind. No matter how far ahead a company may think it is, competitors like Sierra Space are proving they can not only catch up but possibly even surpass them. This rising momentum is putting pressure on Boeing, especially since their once promising Starliner has struggled with repeated delays. The contrast between Dreamchaser's recent progress and Starliner's ongoing issues is growing clearer, making people question if Boeing's spacecraft still has a meaningful place in future NASA missions. At one point, Boeing's Starliner was considered the frontrunner, clearly ahead of Dreamchaser. But now, it's stuck in a cycle of delays and technical hiccups that make its future uncertain within America's crewed space program. NASA's Commercial Crew Program has already invested a staggering $4.2 billion into the Starliner project. Yet, despite this enormous financial backing, the spacecraft has struggled to meet expectations. Its development has been bogged down by delays, design flaws, and a series of technical mishaps that have slowly chipped away at public trust and confidence in the spacecraft's capabilities. Take Starliner's very first uncrewed test flight in December 2019 for instance. It failed to dock with the ISS due to something as basic as an internal clock error. That small but critical glitch threw off the mission's entire timing, forcing NASA and Boeing to abort the docking and bring the spacecraft home early. The problem highlighted not just technical oversights but a lack of readiness for a mission of such importance. These kinds of missteps are costly, not just financially but also in terms of reputation and mission momentum in a highly competitive space environment. Then there was the second uncrewed test flight, scheduled for August 2021, and never even got off the ground. Engineers discovered several stuck fuel valves in the propulsion system just hours before liftoff, and the mission had to be scrubbed. This added yet another delay and raised more questions about the spacecraft's reliability. People began to wonder, how many more chances can Boeing get before its credibility starts to wear thin? The growing pattern of technical problems and mission cancellations has been frustrating for both NASA and those watching the program closely. When Boeing finally scheduled the first crewed test flight in June 2024, many hoped it would be the turning point. But once again problems surfaced. Engineers identified 5 helium leaks in the propulsion system's pressurization area. On top of that, 5 out of the spacecraft's 28 reaction control system, RCS, thrusters were found to have issues. Some Teflon valves may have overheated and dislodged, affecting the fuel flow. These problems delayed the mission yet again and raised concerns about whether Starliner would ever be fully ready, especially with the ISS set to retire in 2030. Of course, in any high-stakes field like aerospace engineering, failures are part of the process. Rockets and spacecraft are incredibly complex machines. But at some point, continued failure becomes less about learning and more about missed opportunities. If these problems keep piling up, Starliner may not even be a viable option by the time the ISS is phased out. This gives competitors like Sierra Space a real opening to take the lead. Unlike Starliner, Dreamchaser has been quietly but consistently moving forward, winning confidence through successful testing and a clearer development trajectory. While Starliner's technical troubles dominate headlines, Dreamchaser has been steadily advancing toward its debut mission. Both spacecraft have faced challenges, but Dreamchaser's path seems more straightforward and achievable. With 6 cargo flights to the ISS already scheduled and successful simulation tests at Kennedy Space Center under its belt, Dreamchaser is not just catching up, it's potentially pulling ahead. The public perception is shifting, and the contrast between the two programs is becoming more noticeable with every passing milestone that Sierra Space hits without major setbacks. Dreamchaser and Starliner represent very different design philosophies. Dreamchaser features a lifting body structure that allows it to glide and land on runways, while Starliner follows the traditional capsule model, descending by parachute. Dreamchaser's unique shape offers big advantages. It can land on conventional runways similar to a commercial airplane, which gives it far more flexibility in choosing landing sites. This means quicker recovery times and less stress on both the spacecraft and its passengers. It's a huge plus, especially when transporting sensitive items like scientific samples or medical experiments. Dreamchaser's interior is equally impressive. It offers 33 cubic meters of cabin space, enough to carry up to 7 astronauts. The Tenacity version, specifically built for cargo, can transport up to 5,500 kilograms to the ISS. That's over 5 times the capacity of Starliner, which tops out at around 1,000 kilograms. This massive difference puts Dreamchaser in a much stronger position as a cargo workhorse. While Boeing Starliner is geared more toward carrying people, Dreamchaser is proving it can do both, efficiently, safely, and with greater mission versatility. Starliner, by sticking to a capsule design, does have some strengths. It's built around a familiar and historically reliable system, much like SpaceX's Crew Dragon. But that approach doesn't offer the same flexibility Dreamchaser does. One of the few advantages of capsules is their ability to land on solid ground. Blue Origin's NS-31 mission is a good example of that. On April 14, an all-women crew returned to Earth using parachutes and airbags. But while that landing was successful, it still carried risk. If the parachutes had failed, the consequences could have been catastrophic. That's why water landings have traditionally been viewed as safer, because the ocean can absorb more impact energy. But Dreamchaser avoids both of those risks altogether by landing like a plane. With its smooth gliding descent, it can touch down at virtually any major airport around the world. This drastically reduces mission complexity and allows for faster transport of cargo back to labs or hospitals. It's more efficient, more flexible, and ultimately safer in many ways. Plus, there's no need to worry about deep-sea recovery operations or parachute deployment failures. To withstand the heat of re-entry, Dreamchaser is equipped with 2,000 high-performance heat shield tiles, each 10 by 10 inches in size. These are similar to the ones used on SpaceX's Starship, and they're designed to protect the spacecraft from temperatures reaching up to 3,000 degrees Fahrenheit. This allows Dreamchaser to avoid needing an ocean landing just to manage re-entry heat. The result is a faster turnaround, better performance, and a spacecraft that can complete missions more quickly and more often than capsule-based designs. Despite the minor delay with its Tenacity variant, Sierra Space is still pushing forward with bold plans. In addition to ISS resupply, the company is heavily invested in the Orbital Reef project, a commercial space station that could launch before 2030. Dreamchaser is expected to play a key role in transporting both cargo and astronauts to Orbital Reef and potentially other space destinations, including private space stations. There's even speculation that Dreamchaser could partner with larger spacecraft like SpaceX's Starship, supporting orbital platforms that are still in the early stages of development. The design of Dreamchaser resembles a mini version of NASA's retired space shuttle, and that's no coincidence. It borrows heavily from decades of experience but modernizes the concept for today's space economy. It's also starting to emerge as a serious competitor to SpaceX's Dragon, something Starliner has yet to accomplish. Unlike capsule designs that rely on parachutes and steep descents, Dreamchaser's lifting body design allows for a gentler, more controlled return to Earth. That approach isn't just safer, it's more comfortable, especially for human passengers who might not be trained astronauts. This design spreads out the heat load more evenly and lowers the G-forces passengers experience. While re-entering in a capsule can expose the human body to up to 6 gs, 6 times your body weight, Dreamchaser reduces that force down to just 1.5 gs. That's a game changer for passenger comfort. Lower gs mean less physical strain, which is particularly important for longer missions or space tourists who might not have military-grade endurance. It's yet another example of how Sierra Space is designing for the future, not just repeating the past. With all these features combined, Dreamchaser is set to reshape how we think about space travel. It brings the comfort and precision of aircraft landings to the harsh realities of space missions, making space more accessible for everyone, from seasoned astronauts to the space tourists of tomorrow. As the landscape of commercial spaceflight continues to evolve, Dreamchaser stands out not just for its innovation, but for how well it adapts lessons from past designs into a versatile platform ready for what's next. The future looks bright for Sierra Space, and it's only just getting started.